Good morning again to everyone. Welcome to the TestCom Tools track, second session. I'm Martin Gijssen, and you have tuned in for the session by Gil Zilberfeld. Gil is an independent consultant on agile quality, and he is on a mission. He wants to abolish the discrimination of test code. It should have the same rights as production code and be kept just as clean. And he will not only explain the value of clean test code, but also demonstrate how to apply it on examples of test code that contain anti-patterns in this sense. So here is Gil Zilberfeld on dirty tests and how to clean them. Welcome.
Thank you. Thank you. Hi, everyone. Nice to have you here. I hope you're already having a fun TestCon here and you're learning a lot. I hope you learn a few things from this session as well. I'm going to talk about test code, automated test code, that is, and how we make it a bit cleaner so everyone can enjoy it, including less work for dogs, as you can see. So a bit about me. My name is Gil. I'm a consultant, and I work with developers, testers, everyone who wants to create better software, and all kinds of things, automation. Talked about this, clean code. From unit testing to API tests, I'm giving a webinar in 2 weeks about expert tips for Postman automation. So you might want to join that. The author of 2 books, Everyday Unit Testing and Everyday Spring Testing. And that's about probably what you need to know about me. So people ask me, Gil, do you write clean tests? And the answer is, it really depends. And the reason is that it's really hard to write clean code by itself. And we'll talk about what that is. Clean tests, it's even more so. And a couple of reasons behind that. And if you catch me, like if I write code or tests and the same day, that's okay. I probably say, well, I'm done, right? I'm moving to another thing. It's probably the best thing I can do right now. So yeah, it's okay. But 2 or 3 days later, I'm looking at this code and I look a bit like that. So, and that's okay because code doesn't really get dirty or clean. It's like our perception of the code. There's a couple of reasons where it's not really me. It's not a lot of people who write automated code, automated tests, feel like that, and I see a lot of that with my clients. And there's a couple of things that test code and production code are basically we written a bit differently. Why is that? Well, first of all, it's like I said, it's a perception in our mind of what this code really is, and even though like we know that it's code like any other code, it's we don't perceive it as real code. It's like production code. Interesting. If we write unit test or API test, doesn't matter, end-to-end test, like these are not perceived for us like real code, therefore they're not that important for us. But there's a bit more than that. Like when a test passes, we kind of a feeling, hey, we're done with it, we won't see it again. What's the chance of us being looking at that test code again? It's a bit different than when we're talking about real code, right? Code, we even if we test it, even if we debug it, we have it in our back of our mind that we are going to get into that again. Therefore, there needs to be some kind of investment of cleaning up that code. Tests, we kind of do like test by test, right? So when we're done with this and this one passes, we probably won't see it again. So we don't go back to that. And another thing that we do with tests is that once a test passes, we kind of copy it and do some kind of small changes to it, because the next test is a bit more like the last one, but with the changes. So we can accumulate a lot of like bad code because we're copying it a lot. So basically, we don't apply the same standards. Now, if you talk to developers, I do. Basically, I will show you the next slide, and they usually they agree with what I show them. And when I ask them, what's your job? And the job of everyone who writes code is code that works over and over again. Code that works, yeah, makes sense, right? Like even if it's production code, yeah, it better work. Test code, that's true as well. Over and over again, this reminds us that we're going to go into that code again and again. And we're going to do that. We want to not make mistakes. We don't want to risk breaking something that already works. And we want to go in and out of there as quickly as possible. So we need to convince ourselves that tests are real code. So we need to treat them the way we treat clean code. Again, if you're treating your code with no standards at all, then yes, you have the same standards for test code, assuming that you even have tests. But if you have like some investment in your code, we actually want to apply the same standards. So what is clean code anyway? So before I go like throwing like definitions at you, my perception of clean code is why do we need that? Like, computer can understand whatever we throw at them, but it really is about time. So like I said, I'm going to go into this code again in the future, so I'm investing in it now. Why am I doing it? Because I like to work on new stuff, on new features, not on bug fixes, not like rummaging around, understanding what this bit of code does, and I want to be careful not to break it. So I want to spend as less time as I can with this like future code. So I'm investing in it now. So when we're doing like investment, like clean code investment, it doesn't matter if it's code or the test themselves, we're kind of caring about the time of ourselves or somebody else's in the future, because they also would like to work on the new stuff. Now, you might have seen this kind of comic before. This is like the difference between good code and bad code and how you measure it. And it's funny because, well, it's funny, but it is important to understand that the only way to qualify if code is good or bad is let somebody else, a human, check it for you, read it, see if they can actually do something about it, understand it, willing to go into it. So yeah, we actually need to do that. So I, like myself, I can tell you that my code is clean or not, but the only way you can be the judge of that is if you look at it. So a couple of definitions. Clean code is simple, direct, should be written like prose. And this was said by Grady Butch, one of the greatest nations of code, one of the people behind the object orientation movement. Yeah, and you should think about your code, and I'll apply this to test in a minute, but can you read code like a book? Is it written like a book? It is. I know. Michael Feathers, who wrote, I think, the Bible for unit testing. It's called Working Effectively with Legacy Code. He wrote that clean code always looked like it was written by someone who cares. Cares about what? Like other people, maybe their time. So we're writing code for other people, not for the computer. Here's another one from Martin Fowler, who's one of the authors of the Agile Manifesto, the refactoring book. Very good. He said any fool can write code that the computer can understand. Good programmers write code that humans can understand. And again, it goes back to the same thing, that people will be the judge of how good your code is. So basically what we want is not just clean all the code. Let's see how it applies to actual tests code, because that's where we're here today. So what makes clean tests? So it's not a total list, but I think these are things that are important when we're looking at tests and defining what is important for us and what makes tests better than other tests. The first one is that they show intent. So tests are basically examples of how to use the code. It doesn't matter if it's a unit test or an API or you're operating a screen or something in a mobile. It's examples how to use the code, and there's an intention there. We're going to use this in this part of the code in this kind of scenario, some kind of a setup, and we expect some kind of result, and we want to see that from the code. If it's not, if it's hard to see, we will, not given enough time, we'll be able to understand what it does. But if it's hard to see what it's doing, we kind of miss an opportunity here, because again, it will help us make less mistakes and be out of there in time. Second thing is something that you can apply like to small bits of code and therefore small bits of tests, like unit test or something like that, but that's not all. So, and that's the focus. So there's something called an SRP, so single responsibility principle, which comes from solid and clean code. And basically, it says that code, a piece of code or a class, you can expand that, should do one thing and one thing well. Single responsibility. Now you can do that for like unit tests, like test a function, something like that. But if you do a workflow, for example, let's say you operate a web page or a couple of web page, like an SS workflow. It operates a lot of code, true, but it does a lot of things, and if it does a lot of things, it can fail on on all kinds of things. Therefore, it's hard to know what this test does and what it focuses on. Now, I don't say like don't write big bunch of workflows, workflow test, but understanding what the test does, and basically, if you want to compare this kind of test and its brother or sister test, which do most of this stuff but something different, it's hard to see that when they're doing a lot of stuff. So good tests kind of focused. I find it like it's like funny to say that, but it can be a problem. Like tests should say what they're going to do, and basically it could be coming from the name of the test or the description of the tests. Sometimes like comments in code, they don't really do that, or they don't really do that well. If they do, we have good tests. The final point I want to mention here, and I'm going to to show you that, is that it's the abstract implementation. So you know, if you've written one single test in your life, you're using like, let's say JUnit. I'm going to show you a test with JUnit today. So JUnit, a test framework that was not written for you, it was written for everyone. And that's true for JUnit, it's true for, I don't know, Spring. Any framework that you're using is some kind of a general purpose, and therefore it doesn't have like a finance flavor, or it doesn't have like medical flavor, or I don't know, Facebook flavor. So what happens is that we kind of mix things in our code, mix languages. There's the application stuff and there's the low-level doing stuff, sending messages to Kafka. This mix of languages is hard to read and therefore understand. And if you think about reading a book, like we saw before, think about a book that's written in two languages, how easy it is to read it. It's not. And we write code like that all the time. So we want to fix that. We want to make sure that our languages don't mix in our tests. So there are things called code smells, and I'm going to show you test smells. Code smells basically anti-patterns of code, how to not write code. And it's not like how not to write code because it's not right. It's because maintenance cost is bigger. So if it's not clear, it's going to be like harder to understand and harder to maintain. So in what we're going to, I kind of borrowed a couple of anti-patterns or test code smells from clean code principles. I'm going to apply them to tests, and that is first thing is a pattern called God class and God methods, like giant ones. You've probably seen ones. Bigger pieces of code are hard to understand. We'd like pieces of code that fit in our mind. No, know about you. My mind's very small. Second thing about comments. Comments is recognized as a code smell, like, because we may change the code, forget to do the comments. It has the same implication in tests as well if we write comments in the tests, but also I'm going to mention about the name of tests as well, because I sometimes write a test, I have like a description of what the test is going to do, start to write the actual code of the tests, forget what I want to do, so I do something else, and then I forget to change the name. And that's a problem, because the first thing that we do when something fails is the name. So we look at the name, we look at the code, so how these two relate, which one's correct, what's happening here. Again, it's not something that is going to break our world, but it's going to take time to make sense of it. Uncommunicative names, yeah, well, you've probably seen this one I'm going to show you today. Like test 13 is not a good name for a test. And the final thing I'm going to talk about are embedded constants or literals. Things like you see, like get user with a user ID equals 17. Well, what stands behind this 17? Is it is a regular user? How is 17 different than 18? Same, going to have a different behavior. I don't see that from the test, and these are like magic numbers, magic strings. In the test, we probably want to give them better names and make sure that they actually talk to us in a way we will understand. So yeah, demo. Let's do that. So I'm going to switch out from this to IntelliJ. I'm going to show you this in Java, but the principles are like regardless of what language you're using. What I'm going to show you is basically a calculator. Of course, everybody shows calculators in their demos. Why not me? It really doesn't matter, because what it does, what you see here is basically a Spring controller, an API with a post called calculate. That's what it does. It gets a calculator params object serialized into that in the body, and it does something with it. It really doesn't matter, because I'm not going to talk about this. I'm going to talk about the tests. So that's basically it. So you know what we're actually testing. What is interesting about it, I'm going to use that, is that I do have in the production level code, have these constants that I'm going to use, like the root and the path to the URL. That's basically it. Right, let's close this. And this is the test I'm starting with. So basically what we have here, the test class has something called a test add, which is a very cool name. Check that we can add two numbers and return the right result as a string, because that's what it does. We kind of calculates the thing and returns it as a string. Comment is correct. Basically, the name is correct, and not good enough. We'll try to fix that as we go. We have the calculator params object. Basically, it's a data object. I haven't showed it to you, but it has a set first, second, and get first, get second, and set operation. So it's like an object that has a first, second, and operation. It's like data object. It's going to be serialized, like I said, in the body. So basically, I'm setting this is a 3+4 version. And then comes like the low level stuff, like I'm creating a headers and filling it up to I want to sending JSON, and then this thing I'm serializing the object, sorry, to JSON, and then sending the request with the REST template because it's very old code to a local host with the API, and finally I'm checking that the result that we got from the request is 7, which is okay. And then, like we do always, we kind of take this test and copy it for a next one. So you see it's very similar to what we do here, only this time I'm adding -5 and -4, going to have -9, and I gave it like test add minus. I copied the comment because it's still correct. And then for the next one, I got even tired of copying the comment, gave it something like called subtract numbers, called a test minus, and this one does 20 -4. That's basically, and that's like a very small collection, 3 tests. And you can already see that this code could look a lot better, right? So let's make it a lot better. So I'm going to go with you, not live, but for the changes. And the first thing I'm going to do is something that you can do with any test framework, and that is like have a setup. And in JUnit 5, it's called before each. And if we have a common setup, we kind of copy out a lot of the noise outside. And then what we do is basically all the things that we create in the test, I'm going to create it in the setup object and initialize it like this. And I'm going to create fields here in the test class itself. And basically, look how it makes the test like shorter already. We said smaller is better. So that's obviously first thing I want to do. And there's still the application to remove, but I'll keep that for the step after. The first thing I do want to do, though, is look at the comments and the names. They're not that descriptive. A lot of the times you'll see like repeating either comments or names, because you remember what we're doing here is like the same thing, calling it the same API, but with different parameters. We kind of push ourselves into how is this test different than another. So better names. So I remove the comments because I don't need them. I'm using better names like add to numbers and calculate result. That's the first one. Second one, add two negative numbers and calculate result. And the third one is subtract two numbers and calculate results. Now, yes, of course, it makes sense. I do want to mention that something I mentioned before. When something breaks, the first thing we'll see is not the code of the tests, is the name of the tests. But what we'll also see that maybe this one is different than this one. This one might be passing while the second one might be failing. So the differentiation between the test names is important. You already see that calculate result here appearing in all tests, and it probably will be because this is a calculator, right? So maybe that's the application as well. I might want to remove that as well, which is my next step. So removing the application. So what do I do? So setup stays the same. I'm kind of, what I did was create a method, extracted a method called calculate, which I'm passing the URL into that. And again, tests are shrinking. That's okay, because what we want from them is basically not create common code. This is why we removed the application. But remember, what we're trying to see is how is this test different than the other? So we kind of keep what is different. So we have here all what's left. And at the bottom, we have the call calculate, which gets the string itself, and it does the common stuff. The JSON thing, JSON serialization, calling the request and getting the result out. Now, one thing I did here, and I kind of looked at it and said, well, you know what else is duplicated? This parameter here. It's always the same API. Why do I need to pass it? So that would be my next step, to take the literal and see what I'm doing. So let's look at the literals. So the first thing to do is obviously is to create a constant local URL. Don't need to pass it. I gave it a name which is a local URL rather than maybe something that's going to be used in an integration test or some another environment. So now I'm calling it local URL. I removed the parameter from here, so just being used in the call calculate method directly. Where is it? Here. But I can do something more than that. So look at this URL. It kind of comprised of two things. This thing is part of the configuration of the test. It belongs in the test world. These two are coming from the API world, and if I leave it like that and the APIs change, my test will break. So I can even that I can take and break them into two things. So I can create the local URL, which is just this, the local URL. And then I can create a URL that is comprised of the local URL and the other consts from the production code, which makes the test less fragile. And then I'm using the URL here, creating in the setup and using it in the call calculate. So that's cool. Look at what we have right now. We have like some very small tests. We kind of moved around all the things that duplicated, moved it to different the top and the bottom. And we can actually see the differences. But this is nice for something with 3 parameters. Um, what happens if we have like a giant JSON file or JSON data or like a tree of objects? The test will still be like giant things, right? So what we want to do is maybe use a pattern like a builder. So a builder basically takes it's a builder is it kind of it creates a data objects for me. So I give it like with first and second and ops. It kind of looks like my initialization before, and it has a build method and kind of creates the data object, sets everything, and returns it. And it may look like, what did you do? Like, replaced, you even wrote a couple of more lines for it. But see, that the cool thing about builders is this, the defaults. Because if the defaults are here, or you get them for a template of a file or something like else, what you can leave out in the test is the difference between them. So let's look at the test now. Test with the build will look a bit like before. The setup is the same, but this time I'm creating the calc params with the param builder with first, with second, and build. And note here that I didn't say with ops because the default is plus. Now here it will be like, yeah, by removing the op, you might be like hiding stuff that we might need for later or for better understanding, and that is true. I may define, I may want to use that, but as this is an example of what you can leave out if you have like giant data objects when you just need like to set 3 fields or so, and the rest is before. And again, it will shorten the test because the rest of the creation of the data object is somewhere else. And again, what we have in the difference between this test and the next one is really the different values here, or in the negative one where the operation is with minus, I do have with ops here. So I'm keeping in mind, so what I want is like leave the different the differences between them. Okay, cool. Not done yet. Remember, I talked about talking in different languages inside the code. I'm going to skip back to the beginning that we have. This is an example of the test that speaks in different languages. These things, the calculator params, and what else? No, that's it basically. Comes from the calculator domain. Operands, first and second, what is the operation? All the rest of the stuff here is very low level. It comes from Spring. It's operating REST APIs. It's a different language. And kind of mix that. If you can think about, well, I'm calling like a single API. What happens if I call multiple APIs? and I kind of do deserialization, serialization, and mix application code and logic with domain or platform code. It's going to be messy. It's going to be hard to focus about what's interesting in this test opposing other tests. So we don't want that. So in our code right now, we kind of extracted away the low-level stuff, the call calculate, because now the platform stuff is sitting in this function, which is cool, but we can do even better. So what can we do? So look at this code. It's basically calling an API in some way, a post for post API, takes the argument, takes something, serializes into JSON and sends it. Basically, I can move this thing into another class called API call wrapper. And now this class has the headers and the media type and REST template and object mapper, all the platform stuff. And I created a method called post with body, which has the same thing as before, but this is another class, a platform class. Now my code that basically calls this class test basically looks the same, but my call calculate now calls the API call wrapper. And the post with body method I created basically gets a URL and an object. Where is it? And basically becomes like a wrapper for any post method with a body that you want. So it can be reused, not just by my test or test class, other test class as well. And yeah, I kind of show you one test class until now. You'll have many, and you'll perform these things over and over again. So you'll duplicate code not just inside one class, we duplicate over and over again. So pushing that, extracting that into a separate class makes sense in terms of duplication. Final thing I want to show you is something called differentiation. So remember I told you, let's see my test before that. So we have these things using our builder like this. So I gave you the example of the user ID, which one is important. And I can show you an example, not a separate one, but something like this using here. So how I use differentiations in constants in order to specify numbers. So if I had like a number, I would call it any number. The number 20 is being used in the here. So if a number or a user ID or another operand is, it doesn't matter to me what the value is. It could be like tomorrow I can replace it with another. I will call it any something. And if something is important, I will call it the something. And suddenly it becomes important. What are the interesting things or important things to pass the test in here, in this test or tests, and what is less important and could be replaced and would not break it. We kind of focus the reader of the test to understand what is important. And these patterns that I've showed you and the operations I've showed you of refactoring basically can take your test to less application, more abstraction, and again, focusing the user on what is important. So I'm going to switch back to my slides now. So what we did is called refactoring, basically. It's kind of a lie, but that's okay. Refactoring means changing the code without changing the functionality. How do we know we haven't changed the functionality? Well, with code, it's easy, you know, because you had tests before, test run, they have the same results. But we don't have tests for our tests. So we assume that our tests do the same thing as they did before because they're still passing. What did we look at? We looked at patterns of God classes method, but look like giant, medium-sized tests that could be giants. We kind of squished into only what is important about this test, and we can look at how is this test different than this one. We took out the comments and irrelevant noise kind of kept in the names, and if we did have comments, it is really important about this. The uncommunicative names, kind of replace them with better names, and even then we identified duplication and remove that. And embedded constants, we kind of played with the literals and said what is important for us in this, and we try to tell the story within the tests. So test code and production code, we should treat them similarly. That's the same standards, um, same processes. We refactor something, we do refactoring both in production code, both in test code. We review production code and test code the same way. Yes, the same way and a good way. That means that when you're reviewing code for somebody else, and the good way means that you're actually sitting on their computer, or they're sitting in yours and you're looking at the same code on the same screen at the same time. You review that, you review not just the code but also the test code. Make sure that what is important for you, if you're doing the review, if you understand the production code, you understand the test code as well. And the final thing of how we treat our test, what the standard is, if you decide there's going to be some kind of fixing, refactoring in the code, same standards apply to the test. If the tests are not that clear, they need refactoring as well. So this is our goal, and basically this is how we get clean tests. This is what I wanted to share with you today, and I'll let Martin ask me questions if you ask him questions. If you want to get in touch with me regarding everything I talked about and more, uh, things appear on the screen, okay, or anywhere else. Thank you very much, and thank you for coming today. And other questions?
Yes, thank you, Gil. That was a really interesting, practical also presentation on how to keep test code clean and shiny. Um, Especially the various examples of removing duplication, giving more
Mhm.
compact and readable code were quite clear. So there was I saw a comment that said that the unit Stefan is mentioning that the JUnit 5 allows us to send parameters, and we
Mhm.
can have one test with multiple parameters. So all this parameterization flexibility, I suppose, is very useful for this.
Um, ooh, Parameterized testing. By the way, you could do it with JUnit 4. You can do it like almost any framework has some kind of parameterization capability. Um, so the funny thing is that it's very easy once you know how to do that, to write these kind of tests. But once you pile, like, I don't know, 5 cases that you're going to run through this test, you basically, when you look at it, you kind of look at, well, how is this test case different than this one? Are they the same? Are they doing something completely different? What you're missing out with not writing like a test name for the test case is information that will be probably helpful for you when you're reading the code for test code, not not when you're writing it. So it's not a bad thing, but even if you have like something like that, even you can take it like a different way. If you have like whatever algorithm that you're testing, kind of throw numbers at it, and you have kinds of a result, you probably want to segment different groups of these cases, check this thing, and these cases, check that thing, and usually we describe that in the name of the tests. So you probably want to do that. You can play with other like messages or comments for test cases like that, but try, even if you're using like parameterized test, try to group tests differently, like maybe if it's the same test completely, Give it a different name so you'll know that this group checks one thing, this one is focused on another.
Thank you. Another question. Does it make any difference whether a test case is a unit level test, a service level test, a system level test? Of course, a system level test does more, performs more activities. They're more complicated. So does that make any difference for the story you just explained to us?
Well, the refactoring rules are the same. You want to remove the application, you want to understand what it is, you want proper names, and you want to see the differences between things. So the only difference is like the scale, right? If you're doing a unit test, it's a function name and a class. If you're doing like a whole workflow over multiple pages, it will be like a longer sequence, but then again, maybe you don't need the entire sequence to tell the entire story. You can split it to different chapters, like in different tests. So try to think about what you're trying to do and what you're trying to convey in your tests, not what you're operating, which is a different thing, because you can operate like I showed you. Nothing changed in terms of implementation of what I did. What did change is where the code was located, how things were separated from each other, and what it meant for the user. So you can write it like in zeros and ones, right? Like, computer will understand that. Try to think like, where does the next code go? Does it tell me the story of what I'm actually interested in? The longer the workflows that you're testing or APIs or whatever, it will be hard to answer, at least from this kind of perspective. How is this long test, different from its brother? And therefore you're pretty, why is this passing, why is this failing? So from now on it will be like, yeah, the longer it is and the more unstructured it is, it will be hard to debug, to understand. That's always true. In terms of how clean the code is, how easy it is to read, try to think about what you're focusing in and not spreading your languages all over the place.
Mm-hmm. Thank you. And how do you see the relationship between static code analysis that will help you find things that might be improved and the review that our fellow automators or developers or testers or any other team member might do for us?
Okay, so it's a very good question. I actually did like a review of SonarQube rules like a while ago. SonarQube is a tool that does static code analysis and finds all kinds of things. First of all, let's start with any tool doesn't understand what it's reading, right? It can count stuff, like it can tell you like your function is like 1,000 lines of code. That's probably bad. Okay, same true for tests. But if it's like 20, is that good or bad? Sometimes it's good, sometimes it's bad. But depends on the language, right? If it's Java, it's going to have like braces and stuff like that. Kotlin will be a lot shorter. So that's one thing. So it can tell you if things are moving out to the extreme and therefore you should treat them. There are tools that find duplications, not just exact applications, but also similar duplications in the code, which can help you. But no code reader will understand if something is telling a reader of a certain specific application if it's doing it right, if it talks the same language, the specific language that needs to be understood. Yes, it can see that variables are being exchanged, but what do they mean? And if they are important, you need a person to do that.
Yeah, which relates to your meme about the code reviews.
Yeah.
Because it's people that have some, well, it raises some questions. And actually, as time progresses, actually, you yourself might be the person saying, what idiot wrote this? Oh boy, it was me.
It's me. Yeah.
Yeah.
Happens every time. Yeah.
Yeah. That brings us to the end of the scheduled time. Thank you very much, Gil, for your interesting chat. Being a coder myself, I could very well relate to it. I would encourage people to rate this session, and so that that will also count to their eligibility for the ebooks that Manning and Packet are awarding at the end of this conference. So thank you all very much. See you at the
Thank
next
you.
session.
Bye bye.
Bye bye.